So hey, welcome back to another video. In this video, we will cover some basic concepts of Centroid. Yep, no numerical questions is included in this video. Just some basic theory portion for it. So definitely short and crisp will be this part. Just a second, guys. Okay. So what I was saying that here I have pre-written some thing which includes definition of centroid and some formulas for it. Now centroid is geometric center of object. Okay. Now this geometric center helps us to evaluate the calculation of moment of inertia and definitely many more quantities. So to mathematically evaluate geometric center of an object, uh, here is some formula. Summation of x into L divided by summation of L is the x coordinate of centroid denoted by x bar, and similarly y bar has been denoted. Now this summation is being expanded. Now what is this L1 and L2? This is actually the distance of centroid of some pre-evaluated standard bodies. Now what are those? For example, a rectangular lamina, triangular lamina, right angle triangular lamina, semicircle, circle, quarter circle, all that stuff. So what are the formulas for that? Yeah, or we can say what are the values for their coordinates, right? So if this is a square lamina, hope so it is clear. Not the square lamina actually, but the rectangular lamina. And let's say its side length is b and a respectively. Now its center will be located in such a manner that if we pass two symmetrical axes, so this distance is gonna be b by 2, and this is b by 2, and a by 2, and a by 2 similarly. Now for a right angle triangle whose base length is let's say b and height is h, so wherever the centroid has been located, if I pass two symmetrical axes and mutually perpendicular also, so this distance is b by 3 and this is 2b by 3. This distance is h by 3 and this is 2h by 3. This portion is 2h by 3, okay? And similarly you can locate it for an equilateral triangle. Sorry, not for equilateral triangle, but a general shape triangular lamina. This would be b by 2 and this will be b by 2, and for the height it is gonna be h by 3 and 2h by 3. And for a circular lamina, or if it is lamina, so refer it as disc, so geometric center is actually the center of that circle itself. For a semicircle, yeah, if I pass two mutually perpendicular axes and which is symmetrically distributed through this semicircular lamina, so this distance is r and this is r, and definitely this portion is 4r upon 3 pi. This is to be very carefully remembered, right? Many times many times myself I have forgotten this pi, so please make sure कि आप pi ना भूलें. And for a quarter circle, if the radius of quarter circle is r, so this distance is 4r by 3 pi, and similarly this is also 4r by 3 pi. So these are some standard values which we will be going to use to evaluate centroid of a given object. So there are basic steps to solve it. First of all, I should write steps here, right? Okay, so the first step is check the position of origin. Wait a second, guys. Okay, check the position of origin and xy axes. So indirectly you have to definitely mark origin for the object. And the second point is to divide the given diagram into parts. Parts or number of sorry uh, you have to divide the given diagram into parts and number the parts of line segment. Number the parts directly we can write here. Just a second, guys. Yeah, pretty sure. Okay, so I guess the entire notebook is visible to you now. So yeah, the third step was to measure the length of part and write it into the table. Now definitely this step is for a line segment or a rod like structure. Okay, if these objects are included, so definitely you are going to measure the length of the distance between the centroid of that of the part from origin. Okay, so for the fourth step, write the centroid coordinates of each part. Really sorry, guys, but actually you have to measure the length of part and write it in the table is a correct statement. Now which length it is being talked about here is, now actually this formula for centered is valid for line segments, but for laminas there is a different formula, so I will definitely tell you about that. Yeah, so after that definitely um, okay, so the fourth step was write the centroid coordinate of each part of line segment. And prepare your table. Definitely your table will look like this. Hope so. Okay. So this is serial number, first corner, and then the length of parts, line segments, and then y coordinate, then x coordinate. Similarly, like this, you have to prepare your table. So after that, you have to put the values in formula and get your result. But now for laminas, centroid formula is like summation of x a by summation of a, where a is area, x1 a1 plus x2 a2 and so on. Similar like that, a1 plus a2, so on. And for y coordinate you can do same procedure. Yeah, so this formula is for laminas. Earlier we have studied for line segments. Steps are all the same, but there are some minor changes, that instead of measuring length of the segments, now you have to measure area for the entire lamina or the parts you have divided. Definitely, if you will divide it into parts, the parts itself is going to be a lamina. So you have to measure its area and definitely substitute the value. So its table will look like, first segment is going to be about serial number, then about area, then about its x coordinate, then about its y coordinate, and like that. And you are gonna use this formula to evaluate the value. And there are some sign conventions. That if your centroid of regular shaped lamina is below origin, use negative sign as per for x bar and y bar. Okay. Second thing, if any portion is removed from the given figure, write its area with negative sign in the table. And lastly, use all these conventions actually it can be written as a note. Use all these conventions in the formula, even if in the denominator case, right? So there is a misconception ki if let's say a2 is negative, we are not gonna use the negative sign of a2 in the denominator value, but actually you are gonna use it. So this was some basic concepts to evaluate centroid for line segments and some laminas. Indirectly you are going to given a figure which will include either line segments or either laminas. So both the cases I have taught here. In the upcoming videos we will definitely practice some good questions to get more clear cut idea about how it is being actually calculated. If somehow any doubt is remaining, you can freely ask it to me. And that's all for today. Take care, study well, bye bye.